Okay, now we're going to talk about gaining some understanding of the graph using the derivative and the function itself. This idea doesn't have anything to do with doing a computation and getting a number for an answer. This has more to do with, do you understand the information that's being conveyed by the function and the derivative? In particular, what we're dealing with is whether or not the function and or its derivative is positive or negative. So let's suppose we're given that we know on an interval a, b, on some interval, suppose we know that the function itself is greater than 0 and the derivative is also greater than 0. Now the question is, what sort of a sketch could we draw? Or what might the graph of this function look like? Now, the first piece is, what do we mean when we say the function is greater than 0? Well, the function greater than 0 means when you substitute the x values, you produce a y value which is positive. And we know if the y value is positive, that means the point x comma y must be above the x-axis. So if the function itself is greater than 0, if the function is greater than 0 on the interval, that means that the graph is above the x-axis. And then there's the other side of the coin. If f is less than 0 on the entire interval, that means the graph is below the x-axis on the entire interval. Right? Now, suppose we know that the derivative is greater than 0 on the entire interval a to b. Well, we know that if the derivative is greater than 0, that means the function is increasing on the entire interval. The function must be increasing if the derivative is greater than 0. So this means that the function, if the derivative is greater than 0, that means the original graph, the original function, must be increasing. And if, on the other side, if the derivative is less than 0, that means the function must be decreasing. The graph of the function itself must be going downhill. The function is decreasing. And what's important to remember is, either of these two may match with either of these two. There is no relationship that necessarily requires if the function is greater than 0, that does not necessarily require that the derivative is greater than 0. This may be paired with either of these, and this may be paired with either of these. So any combination is possible. And so, suppose we're given that the function f is greater than 0 and the derivative is also greater than 0. So what that means is the graph must be above the x-axis. This indicates that this is occurring. And the derivative greater than 0 means the function must be increasing. So what might the graph of that look like? Well, it needs to be above the x-axis and the derivative must be greater than 0, so the function must be increasing. So a curve like this, if this is A and this is B, then this curve would meet those two requirements. There are many other possibilities. I'm drawing this in quadrant number 1. Another graph that meets this requirement is, it could be in quadrant 2. This curve, if this is A, if this is B, then this curve is above the axis, that's what this requirement has, and this curve is increasing. That's what this requirement has. What are some other pictures that would meet those requirements? Suppose here's A, suppose here's B. Is it clear? This function is above the axis and the function is increasing. So there are many different possibilities for what the graph might look like. What would be an example of where something would fail? Well, if this is A and this is B, something that would fail would be if either or both of these were violated. If the graph were below the x-axis, that is not where these two are both true. If the curve is above the axis but it's decreasing, is it clear? This does not meet these two requirements. If we require both of these to be true, this fails that requirement because the derivative in this scenario is not positive. Another example where it would fail would be if we had this picture. In this case, we violated the f greater than 0 requirement. So this fails to meet both requirements. And then another quick sketch here. So this actually fails both requirements. The curve is not above the axis. The derivative is not a positive. It's not increasing. This fails both requirements. And so a really good problem for me to write up would be to give you some combination of these two and give you a choice of several graphs and ask you to choose which graph might correspond to those requirements. Or vice versa. I might give you a picture and say which of these several combinations of positive, negative, f and f prime correspond to that picture. So, let's look at some other scenarios. Suppose we're given that the derivative is less than 0. Suppose we're given the function itself, f is less than 0, and the derivative, let's say, is bigger than 0. So this means the curve must be below the x-axis and the curve must be increasing. So a picture that is below the x-axis and increasing. So let's suppose this is A, this is B, a curve below the axis but increasing. That curve would meet these two requirements. It's not the only possibility, but it is one curve that meets these two requirements. All right? And lastly, let's see if we can talk backward. Suppose you're given, this is A, this is B, and suppose that's the curve we're discussing. So on this interval, the question is, what is f and what is f prime? Well, the function is above the axis, so the function itself must be bigger than 0. The curve is decreasing, so the derivative must be less than 0. So this has nothing to do with doing a computation, computing a derivative. This has to do with, do you understand the information being conveyed by these expressions, by these inequalities that you might be given? And how do those inequalities relate to the graph that you're playing with?